Oh, what's all this? What's all this noise in chat? Wait. I'm a liar and a fiend? We waited so patiently like little beasts? What happened? Did I forget something? What's wrong? I was not expecting this. What are we doing? I don't know, physics. Damie, did you see that Germa gave you a shout out for teaching him middle school math? Nice try, I don't teach middle school math. I'm kidding, I could. If he did, that would be literally insane. I don't think he did though. What's up, you guys? What's up? Did I forget something? Is this about me not playing Beat Saber while doing physics problems? Because I have just not. Damie Catboy Tuber. What is it? What is it? What's wrong? Oh, yeah, I didn't say Xinyan Kuai. It's Lunar New Year today, or for me at least, it's Lunar New Year. Some people have already had it. What's wrong? You guys are all in a tizzle. Damie Catboy VTuber? What's wrong? I'm so confused right now. Did I say I was going to start earlier and then I didn't start early? Is that what it is? What is wrong? Damie! I don't know what we're on. We're on chapter 15. They just said fuck it to fluids, I guess. So we're just gonna like finish up all these questions. I think I should be able to do all of them. And then if not, we'll just do some math. What isn't wrong? Emo emoji. You guys are so cryptic today. I actually have no clue what you're talking about. Are you mad because I didn't stream on Friday and we didn't have a drown in Friday? Is it because I don't have my evil mode? I'm just guessing. I'm just guessing. Or maybe I'm giving you more fuel to the fire of the penance I must pay. Okay. I'm just gonna make this really big. Here you go. Oh god, I moved the wrong thing. We don't remember. You don't remember what's wrong? Oh. Wait, why are you always saying my name in caps? Like I'm God or something. We forgot. Oh. Wow. What an awesome... Oh my god, what's happening? Okay. We'll put it... Where should I put it? There's no space. It can go over me. Damie, yeah, that's me. It's going up. It's going up. Go all the way at the top. There you go. My new table. I'm gonna get a little lemonade. Putting it in all caps as always. Oh, putting it in all caps always? It's just, I just feel like you're screaming. You're like, Damie! Damie, please! I had the lovely, enjoyable task of cutting a 5-page English paper I had written down to 3 pages. That's sarcasm. It was really excruciating. Begging for 1 emote? What emote? I can make an emote. 1 Pogger champ. There's a pog. There's a pog for you. Did a little pogging. We do a little pogging? Let me just slurp that very loudly. Okay, I need to like find... Oh, you yelled that your name is a... Oh, I rolled over something. You yelled out your name is a silly? Good job, Damie! That's cute. Let me turn this off for a second while I look at my important information. What am I looking for? Oh yeah. Why is it in the syllabus of this class? Oh, whatever. Or, you know what we could also do? Is, we could do some, if we finish all this, we can do some casting homework for my metal casting class. That could be kind of fun. That could be kind of interesting. I made horses. Oh, did I show you them? Did I show you them, Chad? My 2 horses I made? Wait a second, you can hear them clinking. That's the horse. That's the noise of a horse. Let me show you guys these horses that I made in class. They're pretty awesome. They're pretty dope. They're pretty cool. They're a lot better than a lot of the welding I did. I feel like I have to like show you guys all my little projects I make. This is almost not even a project. It's really they're horses, just like the Damie My Little Pony we drew last time. Call back, right? That's how comedy works. Awesome project. I didn't get to choose. I did not make, like... The horse chose me. Here, I'll just copy the link. Where is he? I can do this. Oh wait, actually I have an image that's... I have a browser source that's just images that I can put this in, I think. Do I? No, I don't. Did I do that at home? Maybe I did that at home. We can add one right now. Browser. Image. Here's the URL. Look at them. Look at these guys. This one is the one on the left is the better one. So he gets this like little, he has like a little cork stamp, but that would dox me if I showed it because it says where I live on it. You can see that like the mane is supposed to be like better, but it didn't really flow all the way out to the corners. But they're pretty cool. Awesome job, Damie! It feels like an acronym. What would the Damie acronym be? What would that be? Dude. Aw, man. I eat. That's the acronym, I guess, canonically. Not a very good acronym. I don't like it. I changed my mind. It's not an acronym anymore. Dude, aw man, I eat. My favorite V streamer. Dude, aw man, I eat. Me when I regain taste. Oh my god. I'm like always congested, so I have not been able to like smell stuff that well or taste stuff that well. I am also like, I feel like this is very in character of me, but I don't know. I like eating food, but if I could eat like only Soylent and sustain myself off of like one thing, I would also do that. Although I would do that for like some things, and then I would like get bored and then be like, I want to eat like a fruit or something, and then I would go eat a fruit. D. Damie. A. Awesome. M. Man. I. Interesting. E. Educator. Damie. Awesome. Awesome man. Interesting educator. It's such a weird way to describe a teacher. Like, oh, this guy is... this guy's interesting. That's what I think about if I were to describe my professors. I'd be like, this guy's interesting. It's a polite way of saying they're quirky. I guess I technically am like kind of quirky. Not even technically, I'm just a cat boy, so... I didn't know another word. Imbecile. Imbecile, that's not how you say it. Imbecile. I'm quirked up. Damie! I'm quirked up? Oh, no. That's so scary. That's not it. Where did I just put this? Oh, I put it up there. Okay, okay, okay. Which one of these have we done? We did 1. We did 6, I think. Yeah. Oh, that's 9. I think we did 9 too. Yeah. 11, yeah. 18 we did. I don't know if we did 25. Yeah, I think we stopped around then. Yep, okay. Wait, did I do 25? I don't know, maybe? 25, you can't really see it. It's cut off a little bit. Let me... Yeah, this song is so good. Dude always meets interesting entomologists. Is entomologists the people who study words? Or the people who study bugs? I can never remember. Isn't there like an etymologist versus like an entomologist? All right. Okay. We have a mass. 200-gram ball. 2 kilograms. 0.2 kilograms, baby. Good ball. It's pulled to an angle of 8 degrees. Okay, it's a small angle. We're chilling. The student with a stopwatch finds that 10 oscillations take 12 seconds. I think we did this one. I can actually just check. That's me going insane. Yeah, we did that one. I like this image because this is not something I did on stream, but you can just see that. That's just like an iceberg that you can just like kind of, it floated past in the water. I'm so normal when I work off stream. I promise, guys. I promise. Okay. When the displacement of a mass on a spring is 1/2 of the amplitude. All right, so that's like, if this is our A, when it's here, when it's in the middle, what fraction of the energy is kinetic energy and what fraction is potential energy? Okay, so when it's at 1/2 of the amplitude, wait a second. Okay, this is not real. This is like, if this is the wall and this is the equilibrium point, 1/2 A would be here. So when it's here. So in this case, we have to do our UE plus UK equals the total E. But our UE is, potential spring energy. 1/2 kx squared. The UE equals 1/2 kx squared. And I guess our total energy is like UE equals so our two options here are, well, I guess I could just do the full one. That would be 1/2 k squared. Full. So that's our E total. And then if we plug in our 1/2 A, we're gonna get 1/2 k 1/4 A squared. So there'll be more kinetic energy because it's an inverse square type beat, because then this plus KE equals 1/2 k A squared. This goes away, this goes away, this goes away, this goes away. No, it doesn't. I lied. That goes away, that goes away. 1/4 k A squared plus basically 3/4 k A squared equals k A squared. And this is kinetic energy. Cool. So that means that they asked for what percentage of, wait, what fraction? Okay, so 1/4 UE, 3/4 KE. Cool. You ever said, you ever said he knew you in elementary school? You were always in the lunchroom bringing a baggie with a sandwich and juice? I did actually bring a lunch to school. I didn't bring juice. I did like have a little lunchbox though, but it was like, it looked like this. It had these little straps, and it looked like a tree. It had like a tree thing. And then I had a lunchbox that was like this, and there was a thing on the bottom. And then there was a zipper here. And like this was the part that was zipped up. There was also a zipper here. And then because I still like made my own stuff. Well, I had COVID for like half of my high school, but I had like a little bento box that was like this, with a little strap to hold on to. Yeah. So I am a lunchbox guy. I do like a little lunchbox. That's an accurate reading of me. I don't know how Germa would have known me in elementary school, because I think I was in school like 10 years after Germa was out of school. Wait, maybe 20. You sound like the type of person I'd bully in high school. I didn't really get bullied because I was like smart, and I didn't really like, I wasn't like an asshole to anybody, so I just sort of did whatever. Also, I just worked in the shop a lot, like the wood shop, so I wasn't really around people that often. I was a little bit of a loner. As a displacement, at what displacement is the energy half kinetic and half potential? Ah. Unprompted bullet. Wait, I don't know what that is referring to. Just you? Well, then you'd be a little bit of a dillweed. I don't know what to say other than that. Don't bully people. We talk about the real facts here on Damie VTuber. Don't bully people. I haven't heard that one before. 1/2. Okay. We can do it like this. I need this and this to be equal. Oh, I guess I could just say then this. I guess I could just say then this. Wait. Kx squared equals total energy, which is 1/2 kx squared, ka squared. So this will be 2kx squared. Well, 2k, I don't know, what do we call it? Like a sub question mark. We can get rid of the k's. So 2a squared. Oh, I guess I should do this. I don't know why I did that. Over 2. Oh! Somebody follow. Whoa, that was... Thank you for the follow, Gunner David? Gunner David? Oh, you can see that. I forgot that that's my... Okay, I'll pull that out. You can also see that. There we go. Wow, we got a lot of people here. Hey guys, how's it going? We're just... I'm just doing physics. This is what we do. We do a little physics. We do a little mathing. I'm hearing Discord notifications. I don't know where from. They could be in my mind. I don't know. I don't like this A. I'm gonna make it something cool. I'm gonna make it phi. Nah, I'm gonna make it lambda. Why not? Why not? Phi some nuts? Sure. I love that you've only sent like 4 messages in my channel probably, and that's like 2 of them. Okay, phi equals a over 4. That's not how square roots work. A over square root of 2. I don't know if I can find the answers to these. So we'll just have to like trust. That seems like about right, right? Yeah. Maybe. Yeah. That could be real. 5? Some nuts? Sure. A2 over... Nah, I'll leave it square root of 2. It looks kind of nicer that way. I don't know why I called it lambda. I probably shouldn't put x in here. I'll do this. That's not lambda. I just wrote 2. I was trying to say 1/2 plus 1/2. Half-life? Yeah. Also, wavelength, but I just like writing it. It's just kind of neat. It's like that, or you can write it like that. I don't really like writing. I guess like torque is fine. Tau. Make it square root of 2 over 2. Okay, I'll do it just for you. There you go. Yeah, I can take a little rationalization. I love leaving things just a mess, though. That's my little chaos. I love just leaving messy things. Ooh, okay. This one's kind of exciting. Can you guys see 41? There you go. Did I say twerking? When did I say okay, maybe I did. You know, clip it if I did. I don't know if I said... I don't know. Sometimes I just say things and then they leave my brain forever. Yeah, that's all I got. That's all I got for you. That's the explanation. Okay, mass of 0.3. Okay, so when its displacement is when x equals 3 centimeters, so 0.03 meters, then I'm 90% sure you said twerking. Maybe I did in your brain. Then b equals, okay, so we're gonna have to do a little cosine, little cosine type b. 0.714 meters per second. Oh wait, no, I read that wrong. 0.954, and then when x is at... Wait, no, okay. Yeah, no, I got that right. Okay, and then when it's at 0.06 meters, v is equal to 0.7114. All right, so we don't have a time. We just have displacement. So we probably don't want to just go willy-nilly making a cosine function, actually. So if this is our equilibrium point and we have our little oscillating thing, maybe it's here, whatever. Our max speed is going to be at our max kinetic energy. And if there's any sort of stretch in the spring, then that won't be the max kinetic energy. So we need to figure out when displacement x equals 0, what is the x equals 0? B equals what? So we can do this. What's the best way to do this? So we know the change in kinetic energy from here to here, which means we know the change in potential energy from there to there. Does that help? I'm thinking we have to do something where we have like an initial condition, and then, you know, we extrapolate that out. But, what we would really need is to figure out the total energy at some point. But, oh, wait, we can figure out the total energy at some point. I'm literally going bonkers. Why would they give us two things? Maybe because we could do it with kinematics? Huh. Well, yeah, we know how to find the potential, so we'll find the total energy first. So E equals 1/2 kx squared plus 1/2 mb squared, which is going to be 1/2 gonna be, oh, we don't have a spring constant. Shoot. But we do have a delta. We do have a delta U. What a strange little problem. So we can find the KE here. We can find the KE here, which means we can find a delta U and a delta K. But let me see. Maybe they just have like a straight up example of this in the book. I assume they do. Maybe they don't, but maybe they do. Oh, I forgot. I also have to look at this. Driven oscillations. That's damping. This is what, 15.6-ish? No. Maybe? Wait, what was it? Oh, sorry, scrolling. How are you guys doing, chat? How you feeling? What book am I using? It is called Physics for Scientists and Engineers, A Strategic Approach. It's not bad. I used it last quarter as well. This is... Oh, it's just problems in general. Huh. Yeah, I guess it is a problem. That would probably be in 15.4 or 15.3. Let me see. Let's see. I love this song. It's such a good song. All of Black's Castle songs are really good. Okay, that's just... Sweet. Do you see the theory that all math books are personalized and nobody has the same copy, so everyone has learned math slightly differently? Isn't that just the every copy of Super Mario 64 is coded differently conspiracy theory, but for math books? I don't think that's real. I mean, I think that there's some truth to, like, everyone uses different books, so, like, technically you learn math differently. But, like, there are gonna be people who have the same book, is the thing. I don't play Super Mario 64, I do math. Yeah. Oh, you're saying we should use that? I mean, I can use that, but they don't use time. They ask for a placement, so normally that means that we don't need to do that, but we can give it a go. That does make sense. Do we have an amplitude? Who am I? I'm Damie, that's me. An amplitude we can get from... oh boy. Oh, we can get... No, we can't get an amplitude from the delta U. How are you backseating a math stream? I've had multiple people backseat math streams. Honestly, I think it's funny. I think it's funny. Backseat all you want. I like math. That's based. Also, it's not math, it's physics. Okay, so if I use x equals a cos, we'll just run with it, right? So then we know also that v equals negative omega a sine omega. So to do this, we need to find, we need an a, which we don't know. Well, I guess we know that it's at the very, like, smallest, it has to be 0.06. But there's still a lot of velocity left. I guess we could use kinematics to find but that doesn't really work because we don't know the acceleration due to the spring, which I guess we could find if we had the spring force, but then again, we don't know the spring constant, unless I just missed that they said the spring constant in the problem, which is a possibility. No. Okay, we don't have the spring constant. So the other thing we would need for this is omega, which is 2 pi f, or 2 pi over t. And we don't really know how long it takes to complete one oscillation, and they don't actually give us any time. So I don't know if we can do it this way. The things that, like, okay, but we can just write down things we know. We know that we have a change from if we go from x is 0.03 to 0.06, we'll have a change in energy that is equal to something. Well, you won't have a change in energy, sorry. You'll have a change in, like, UE and a change in KE. Which we can figure out, which might be useful. That'd be 1/2. 1/2. Oh, shit! We can find the spring constant like this. Yeah, we can find the spring constant. Fuck yeah! Fuck yeah! Okay, we can find the spring constant like this. So... okay, we'll start with delta KE. Sorry, I got really excited there. Because there's only one variable that's changing. The spring constant doesn't change. And we have the x's. Okay. 1/2. What was it? 0.3. Delta v. Delta v squared. Which will be, let me grab my calculator. This will be 0.954 minus 0.714. So 0.24 squared. Cool. Get that, square that. This times 0.3 minus 0.5. Okay, that is very small. Hey, Jimmy, what's up? 0.00864. Why is that so small? Oh god, that's really small. I don't know if I trust that, but you know what? A joule is a lot of energy, so that could be right. Okay, and this is going to equal our delta UE. So that'll be equals 1/2 k x squared. And we know that k, or we know that x squared, 1/2 k, we know the delta x, that's 0.03. So square that. 0.009. And then this is going to equal k equals 0.00864 over 0.009 times 2. Look at that. Look at that. And now we can use this and we can get some other stuff. Because we have the spring constant, then we can figure out what the total energy is, and that total energy will be the maximum it'll be maximum kinetic and oh, okay, cool. 1.92 is actually not too silly. That's a pretty normal number. So now move that. We say max UE equals 1/2 K, which is 1.92. Uh-oh. We don't have an amplitude. Okay. But I think we can find out the amplitude by using one of these conditions. Because if we know how much... We're so close. Okay. There's like one last little piece here. So we found the, at this point, okay, we want to find the total energy. So to find the total energy, we can take that KE that we calculated, this one right here, 0.00864, and then we can add 1/2, 1.92, and then we were at 0. Oh shoot. The Mario sound. Oh. I'm trying to do more sounds. I was DMing last night. My first, well, yeah, my first campaign for a while. And I was just making so many silly noises. Okay, so I can't use this number exactly because that's a delta, but we can change this to be 1/2, 0.3 times I don't know, which one should we do? Let's do 0.954 squared. And then we add this, and then everything's awesome. Okay. 0.03. Perfect. Beautiful. Serendipity. Oh god, let me square that first. 0.954 squared. What's that? Times 0.3 times 0.5. Okay. That's 0.1. Times 1.92 times 0.03, 0.088 equals 0.1648. That is our total. That is our maximum. Wait, that's our maximum kinetic energy. Now the last thing we have to do. That's the last thing we have to do. Let's turn this 1/2 m. So we do v equals the square root of everything in here, 0. So 0.1648 over m. Am I splicing runs? Did I glitch? I don't know what kind of glitch. Is it an audio glitch? Times 2. Square root. Okay. Let's see. Let's see what velocity we get. If it's something awful, that's not on me. Oh, shoot. I didn't add that correctly. Well, I did. I just didn't press enter. Okay. That times 2 divided by 0.0... No, just 0.3. And then this and the square root of this. 1.048. That seems right. That seems right. 1.048 meters per second. Wow, a whole meter. We made it. Hell yeah. Hell yeah. We figured it out, chat. That is a pog. That is a pogging champion. It's the worst words I've ever said in my entire life. Average streamer brain. That took a sec. That was not incredibly pleasant. Wait, somebody said there's banana bread in the common room. Ooh. God, should I go get banana bread? Should I go get banana bread? Oh, I kind of really want banana bread. Should I go see? Oh, dude, banana bread would be so good. Oh my god, it would be so good right now. Or not. If we want... Should we take a little break for me to go run and get banana bread? Like, I swear, it'll be like 5 seconds. Speak now or forever hold your peace, or I'm gonna go get banana bread. I would put on Bill Nye, but like, I literally don't even think it'll take that long. Let me just see what the next problem is real quick. And then I'm gonna go and get banana bread. Oh, it's gonna be so good, dude. Oh, it's gonna be so good. I hope it's not all gone. It's probably not all gone. Okay. Something about astronauts. Astronauts in space cannot weigh themselves by standing on a bathroom scale. Yeah, no. Instead, they determine their mass by oscillating on a large spring. What a silly little silly. Suppose an astronaut attaches one end of a large spring to her belt and then the other end to a hook on the wall. Fellow astronaut then pulls her away from the wall and releases her. What is her mass if the spring constant is this thing, and then what is her speed? Okay, cool. I'm gonna go get banana bread. I'll be right back. Don't riot while I'm gone. I swear I'll just be quick. Chat, there was no banana bread. Oh my god, why are there 500 hydrates in chat? Oh my god. Oh my god. I don't have any water. I can't go. I just got up. I don't have any. Oh my god. Oh my god, chat. What am I supposed to do? There was no banana bread. I can finish drinking this Capri Sun I have. Also, like, drink it. Okay, I'll drink it. It's actually pretty full. Okay. It's not like 500 hydrates worth. Dink my oiter. I'm gonna mute so you can't hear my loud drinking noises. You said don't mute? Okay, I'll do one bit. Okay, I'm gonna regret this so much. I will go get water. I will go get water in a bit. Okay? You can pull that on me. Then I will have to go get water in a bit. Since there's no banana bread, I'm gonna have a little snack. I'm so sad there's no banana bread. Actually, I didn't even see when those messages were sent. They might have been sent like a long time ago. Oh, they were sent a long time ago. Oh no. I just came in there. I was like, banana bread, please. That's really fun. It's really silly. Okay. I guess we're gonna do astronauts on strings after I eat this little snack. That was a good snap. I'm rejuvenated. I'm ready. I'm ready to tackle this astronaut on a spring. Alright. It's so strange. Since I started like streaming math and stuff, it actually is so much harder for me to not do math on stream. Like I like miss whenever I'm doing math or physics off stream, I'm like, oh man, I wish I was streaming this right now. Pavlovian response. Okay, this graph here. So if we want to find a mass, we can do that by, I don't know, what's the easiest way to do that, we think? I think there's some equations about like spring mass equations. Oh, that's not what I was thinking about. Yeah, we can use W equals K over M. That's what I was thinking about. Sorry, not W, omega. So we have our K, we just need a W. Omega. I definitely didn't say that just now. So omega equals 2 pi over T. And our T, there's a little graph here. It's 3 seconds. So 2/3 pi. We gotta square all that jazz, so that'll be 4/9 pi squared equals K over M. And yeah, I'll do it. It's an extra step, but. And our K is 240 newtons per meter. We don't have to worry about units because it's all in seconds, so unless it was in like bleep blorps or something, then we'd have to put in scientific units, but who cares? So we have 9/4 pi squared times 240 equals M. So let's see if that's a human mass. How much do humans mass? Not quite sure about that one. Divided by 4. Oops, divided by 4 pi squared. Does that make sense? 4. Yeah. This and then times 240. 54 kilograms? What is that in pounds? Anybody? I don't know. I'm not a metric user. 240. Wait, no. 54 kg to pounds. Oh, perfect. Yeah, that's human weight. 119 pounds. Equals 54.71 kg. Look at that. So you can figure out your mass pretty easily, actually. You just have to measure this. What is her speed when the spring's length is 1.2 meters? Okay, so we could do that with...
Whenever I have bad mic, I just turn on my webcam mic and then I turn it back.
That fixed it, right? Dude, my tech is so broken. I don't know why. I genuinely, actually, no, I kind of do know why. I have little cat headphones, and I like them. They're not very good, but I like them. But the problem is they were having this like popping in them, and I was like, oh, I'll uninstall the drivers, and then I'll reinstall the drivers, and that should fix it. And then I uninstalled the drivers, and I never reinstalled the drivers. And now, just like at random points in time, it'll just pause all of the sound and video on my computer, and I have to unplug them and replug them back in to fix it. And sometimes it'll just play like white noise directly as loud as possible as it can into my ears, and then I have to restart my computer to stop it. I think it's probably messing with my mic. That's what I had to, if I had to take a guess, that would be my guess at why I turn into wind. But who knows? Who knows? Okay. So delta x is 0.2, not times. And we're in meters. So yeah, we can see the equilibrium point is right there at 1. And then we're going up 0.2. Or they're asking about what is 0.2. So what we can do is, I don't know, it might just be easiest to do energy equals 1/2 K, which we know, 240, times, reinstall my drivers. Yeah, I should reinstall my drivers. Here's the thing, I'm lazy. Yeah. Can I be evil again? Yeah. Yes, I can. So evil. Yeah. You little evil grin. Yeah, and I twirl my mustache. This is the only evil voice I can do. Hee. Can't do a lot of voices, is what I learned when I was doing my campaign, where I had to make up 30 ghosts, and then the party wanted to talk to them all. 120 times 0.4 times 0.4, 19.2. That's a lot more joules, but I guess that kind of makes sense because it's a person. So then, wait, we want to find her speed? Okay. Then E 0.2 equals, oh, sorry, I should say UE 0.2 equals 1/2, 240 times, do all my D&D villains sound like this? No, they don't actually. There wasn't really a villain. Okay, I could DM this campaign for you guys as a one-shot. It's already written. It has like no, I'm just gonna put it in every campaign I write because it's this hot vampire lady, and she asks you to like come and exorcise all the ghosts in her house. And it's really fun, and it's like playable. It's kind of applicable to any campaign. Her house is kind of in the middle of nowhere. She's awesome. I love her. So she did not have an evil villain voice like here. Although I think I did like an old man voice. I'd love to play that. It's not like really long. It's like 3 hours ish, 3 or 4 hours. It's like one session. I'm getting pinged. I don't know why. But yeah, it was really fun. I had a good time. I think the funniest part about it is that, like, you can do whatever you want. Like, the vampire lady is like very chill, but it reveals a lot about like people's ability to talk to women in real life. It's so funny. I love it. It's like there's no real consequence except for your friends dunking on you if you can't pull off whatever you're trying to pull off. It's great. It's a 19.2 minus 4.8. Which is the best kind of, that's the best kind of D&D stuff. So then 1/2 mb squared equals 14.4. So we do 2. Pull that over 1/2. Look at that, look at that, look at that. So quick and fast. So quick and fast and awesome. That's 2 divided by, what was the mass? Like something 54 point, yeah. This and then square that. 0. Wait. Uh-oh. I guess she probably wouldn't be going that fast. Yeah, no, she's not going that fast, actually. She's going like 40 centimeters. Wait, no, not... Yeah, 40 centimeters. That's not a lot. So even if she's going it fast, she's not really going that far. I had to kind of sanity check that sometimes. Like, is this woman really doing this? Yeah, she's chilling. She's bouncing. I'm gonna turn that off for 1 second so I can see who is pinging me. And then turn off my pings. Grr. There we go. There we go. Big win. Big win. Oh, actually, no. People are pinging me in my server. Please. Oh, so I don't know if the person who's asking for math... I'm live right now. If you want to ask in my chat. I don't know what they're asking about. I mean, sure, they can ask. Okay. That, and then we should be good to go. Let me just turn on the little thing again. Nice, cool. All right. Making not great time. Going for an hour, did like 3 problems. That's fine. It's physics. That's kind of how it goes. I'm goofing off too. I'm drowning. Okay. Another little oscillation. Okay, 5 kilogram. Oh, can you see that? 45? Yeah. 5 kg hangs from a spring with a K equals, let me write a little M there. K equals 2,000. That's a strong spring. That is a tight spring. It's pulled 5 centimeters and given an initial velocity of 1. So amplitude equals 0.05 meters. And V max equals 1 meter per second. What are the frequency, amplitude, and total mechanical energy? Okay. We can find omega to find the frequency. Square root of k over m. So that'll be 2,000 divided by 5, which is 4,000. Yeah. Yeah, 400. I knew that. Equals 20. And then that'll be equal to 2 pi f. So 20 over 2 pi equals f. Do that. Divided by 2 pi. I mean, we could just do like 10 over pi. Hydrate again. Oh my god, I don't have any liquid left. 31 seconds. Jesus Christ, that's not possible. What? Wait, frequency is 31 times a second? Oh my god. That's so high. Uh-oh, this guy is going bonkers. 31 hertz? Drink it? Drink what? I don't have anything to drink. Think? Oh, guys, you're killing me. Oh, okay. Let me explain this. I actually do have water. I have 2 bottles of water that are sitting on top of my fridge because I had practice yesterday and I got a water and I put the water down and then I was gonna go get it and there were 2 bottles of water there. So I have like the choice of like, am I just gonna drink someone else's water? I took them because I couldn't throw them out. They're both pretty full. So I could just drink it, and it's like it's not like I don't know the people who were there. So it's not like I would get like diseased or anything. But like it feels kind of wrong to not know if it's mine or not. Sad Catboy tormented by deranged fanbase. Sad Catboy forced to drink unknown water by evil chatters in chat. I mean, I could drink one of those. I could also like pour them out into a cup, and then that would sort of like negate. I feel like the bad. Okay, I'll just pour them out into a cup. If I die from this water, chat. Catboy forced to drink odd substances by scary Twitch chat. The ending will scare you. Yeah, that's my life. Okay. I mean, I guess I'm gonna do it. You guys did redeem like 500 hydrates. Blank stare. Here's my cup that I've got, and the mystery water. Also, I think there's like dust in this cup. Let me try and get a little bit of the dust out. Maybe just a little bit. Damie, don't die? It's just water. It's just like, it's had someone else's mouth on it, maybe. And the dust is not gonna kill me either. I mean, unless it's killing dust. Which I think I have more things to be scared about if there's just killing dust forming in my room. Oh man. This cup is kind of dusty though. Kind of dusty. What if I just... I was gonna say, what if I just, like, put a little bit of water in it and then poured it out the window? But I live on the 4th floors. That's not really a good idea. Sprays water out the window. I really should just bring my own water bottle, but I think it has stuff in it right now. It's just got a lot of dust in it. Give Pino some of the water? Fuck it, I'm just gonna drink it. He's thirsties. Here we go, chat. I drank the water. It tasted like water. I don't have a water bottle for Pino. I don't think I have one. I don't think I have a water bottle for me either. Oh god, more? More? Fine. What if I just poured it on my mic? Does that count as drinking? You guys actually do hydrate me more than I probably hydrate myself. Not that I don't drink any water on the days that I don't stream. But normally when I'm in the math-induced haze, I don't really hydrate while I'm in there. Okay, the amplitude. Did we find that out? Wait, the what? Is the amplitude not just 5 centimeters? Am I going insane? Hello? Yeah, it's 5. It's 5 centimeters. I mean, unless we're talking about damping. Or like 0.05 meters. More? Wait, you just did that again? Oh, Rev. Your power. I guess it'll just have to be drown him Sunday. Maybe I should just say drown him day. Then it could be any day. I'm gonna be such a drown him day? Yeah, drown him day. Like a holiday. What is wrong with you? Well, you guys were complaining about how I never stream on Friday. So you can't do drown him Friday, but just drown him day. Like a holiday, you know? You get off work for it. Total mechanical energy. No, we can just use Vmax, 1/2 mv squared. Oh, easy, hell yeah. 5 times 1. Oh, it's great. 5 halves, joules. That has no ring to it? Drown him day? That sounds so much ring to it. It's drown him day, guys. Time to drown him. Time to drown him. Maybe it can be like, drown him now? Is that any better? Isn't that more evil? I mean, I can change it to drown him now. If you want. Life could be a dream. Buddy badoo buddy bud da 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 ba da doo. And I instantly get copyright strike and exploded. Thus ends Damie VTuber. I want it eviler, as evil as possible. Drown him day, I feel like, is pretty evil. Drown him violently now, Friday. That's fucked. I think that would be against TOS. Actually, that might be against TOS if I said drown him violently now. What is this? Okay. A molecular bond can be modeled as a spring between 2 atoms that vibrate with simple harmonic motion. Dope. The figure shows an SHM approximation for the potential energy of a hydrochloride molecule. I don't know if that's hydrochloride. I think so. Chlorine. Hydrochloride? Because the chlorine atom is so much more massive than the hydrogen atom, it is reasonable to assume that the hydrogen atom vibrates back and forth while the chlorine atom remains at rest. Use the graph to estimate the vibrational frequency. Alright. Drown him sweetly and lovingly and gently and kindly Saturday. I don't know if that'll fit in the title, but I can try. What a beautiful world you've created. Oh no, I just accidentally opened my to-do list. And I saw that I have to do my IME work and I got a little sad. I mean, I love IME. Industrial manufacturing. Resident Sleeper, next game. Next game, but it's just next problem. You guys are like, this problem sucks. Next problem, Damie. We can use omega. I don't know. We can use omega to get frequency. Can I get that? I don't know if I can get omega. Okay, we know the mass, so they probably want me to get omega. Me when I can't drown him violently now. Okay, yeah, cool. We can figure this out. So when the bond length is 0, 1/2 kx squared. Wait, it's not 0. When the bond length is the biggest. The interim point is 0.13. It's going to 0.17, so 0.03. Nope, 4. I can math. Mew and I can't drown him violently now. Damn. Oh, I don't have my thing that drops emotes on my head anymore either. Do I? Wait, maybe I do. Here, wait, let me put something in chat. I have so much cool stuff on my computer at home that I haven't set back up. Here, what if I just send this? Does it fall on my head? No, it doesn't even fall on my head, bro! What the hell? Okay. Damie VTuber's flop arc. Emotes don't even fall on his head anymore. Imagine someone getting so mad about that. God, I watched him when emotes fell on his head. I can't believe that he doesn't do that anymore. Just making up guys is silly. Okay, this is going to be equal to 4 to the negative 19/10th. 4 times 10 to the negative 19th. Jesus. Like 8. Get rid of this. And then divide away this. Look at that. Equations bend to my will. That is my favorite. That is generally one of my favorite parts about doing physics, though, is just being able to, like, rewrite stuff. Okay, 0.04 squared. Oh, God. So 8 times 10 to the negative 19th divided by that thing. 5 times 10 to the negative 16th. That's such a little spring, guys. It's such a little spring. And then we can, what can we do with this? We can do omega equals a square root of 5 times 10 to the negative 16 over 1.67 times 10 to the negative 27th. Ew, but whatever. Divided by 1.67 divided by 10 to the negative 27th. Ah, no. Oh my god, it's so large. It's like time. What the hell? Oh wait, I have to square root it. That's still pretty big. This is going to equal 5.47 times 10 to the 5th. That's pretty dang big, dude. That's pretty dang big. That's a high angular frequency. Jesus, okay. And then this is going to equal 2 pi f. So this divided by 2 pi. $87. Holy moly. 87,185 and 85. That's how many times this happens in a second. Holy bajoli. It's going really fast. Dude, atoms are crazy. Okay, let's do... How many more do I have left? Probably like a couple, right? Oh, we just did 63. Okay, I can do 2 more. We'll do 2 more. We'll end, and then maybe I'll show you guys... I'll show you guys the casting thing. Let me see. All right. Oh, there's a captive James Bond. You guys see that? No way. They got James Bond in here. Okay. An oscillator with a mass of 500 grams at a period has an amplitude that this is like compound interest. I'm not doing this problem. This one right here, an oscillator with a mass of 500. I think I can do that as a damping constant. We're not doing that one. I lied. I lied, chat. Goodbye, 68. I'm just gonna like put a sad face there with a crying. 74 then. Oh, this is just gonna get boxed. 74. I don't want to do damping right now. I'm sorry. I'm sorry. Ooh, a little proof. A little proof. A little proof for me. Ooh-hoo-hoo. Ooh-hoo-hoo-hoo-hoo-hoo-hoo. Okay, that was... Okay, a block in a frictionless stable is connected to two springs having spring constants K1 and K2. Show that the oscillation frequency is given by that, where... Okay. Cool. How do we do this, I guess, is the question. Well, to find a frequency, you need an omega, usually. Find an omega, you can use... Well, I guess we kind of have to break this up into forces, huh? So, Fx is going to equal... it's frictionless table. So we'll have K... or F SP1 going in the negative direction plus F SP2. And this is going to be Kx 1/2 Kx squared, and this is going to be 1/2 Kx squared. I think. Actually, is that true? Yeah. Wait, is it true? Wait. Force of a spring. Negative Kx, I lied. So, this will be K1 x plus K minus K2x. Okay, then what do we do? You can get you can get omega from you can get omega from V max, but that's not really gonna help, I don't think. Actually, maybe we need to think about it in terms of energy. Because V max equals omega A. Oh, this is a real head scratcher. Okay, so when the spring is all the way over here, and this one's all the way over here, that means this is like, we'll just say this is A2, and this is A1. Shit, that's not it, actually. Oh, man. You know what? You know what, chat? Let's say that we don't do this right now, and let's look at funny silly metal casting instead, and then we'll end. This is what I have to do. I have to describe 3 types of chemically bonded sand binder systems. I have to choose an alloy, describe how 3 rigging methods. That's probably going to be sprues, risers, and runners, I'm guessing? I don't know. There's a lot of words. Describe the optimum part orientation. I actually got that one right when I looked at this, so... Oh, look at this. We have ambient temperature curing, gas or vapor, and thermally curing. Wow, so awesome. So dope. Yeah, I don't actually know why they did this because all of the answers are in this other PDF, this other case study. It just kind of sucks because like the case study is this thing, and this is a part that's used in like an American Navy like aquatic vehicle, and it's like it's supposed to be able to like hold just 17 like soldiers, and it's like, man, can you not just give us something that's like, here's a car that's cool, or like here's like a part for, I don't know, like a washing machine. That's so awesome. No, it has to be here's a part for the Navy that you have to make. Thanks for that. But yeah, so instead of doing physics, instead of thinking about things with our brain, you can think about sand instead. That's the takeaway. Chemically bonded sand. It's pretty cool. I like casting a lot actually, because it really oh, that's not it. It really makes you think about like for injection molded stuff, like how, well, it's not really even a polymer class, like it's a metal casting class, but it still makes you think about like making molds of stuff and like stuff that is like made with molds, like how hard it is. It's kind of crazy. And the craziest part is the part that we don't even talk about. Like we talk about making stuff in the molds, but making the actual patterns for the molds is like, that's crazy hard. You gotta like carve it out of wood. Like you literally have to carve it out of wood, the part you want to make. It's like, what the hell? Or I guess you could 3D print it, but like still, it's kind of bonkers. Or you could mill it with a CNC, but like it feels like we've come so far where we're like, oh yeah, we can like, you know, 3D print metal now and stuff. But then you think about like how a lot of stuff is done actually today, and you learn about it and you're like, oh shit. There's still like a lot of manual stuff done in these industries. Anyway, that's my spiel. That's all I got for today. This acceleration problem, I think I have to relate it with acceleration maybe. But anyway, it was a good time. It was nice hanging out with you guys. Thank you for redeeming 500 hydrates. I actually don't know how many. It was probably like 30. I was actually really impressive that you guys had that many. Like, genuinely. I went, what? I went, what? What? I might be back, probably not tomorrow, so maybe Wednesday. I know, it's kind of a long time. It might be Tuesday. I need to figure out when I have things and stuff to do. But yeah, my Thursdays and Fridays are still kind of wild. I kind of want to do some of the drafting work I have on stream with you guys, but I don't actually have that today. I don't have like the problems that I need to do today, so it's pretty cool. It's like here. I think our example was something like it was like this, like you have the different views. So like this is the front view, and then the side view was like this, and then the top view was like, how did it go? It was like this, I think. And you have to like figure out where the different plane changes are. So you have to be like, oh, you know, there's if you project like this corner out and you project this corner out and you project this out and this out, then you can make like a line here that's 45 degrees. And you can be like, oh yeah, this feature is like here on this part. It's pretty neat. It's pretty fun. It's like a little puzzle. It'd be really fun to do on stream. And then like you put this one over here and you're like, oh, well, that goes like that. And then, yeah. Oh, well, that goes like that. Realize, oh, that's that like that. Yeah. It's cool. Classic mechy type stuff. Yeah, so I'll probably, oh, also, yeah, Happy Lunar New Year. If you I back? Am I not wind? Okay, whatever. Have a good day, guys. I'll see you when I see you, and have a wonderful week. Okay, goodbye.